Now in today's video lecture we will go through quantum numbers, right? So quantum numbers is very important topic, right? So word quantum, why we say it as quantum numbers? Firstly, these quantum numbers will tell you the exact location of an electron or of all electrons in an atom, right? That is, if we know that electrons are revolving around the nucleus, right, in different energy levels, right? And these are not orbits as we discussed in quantum mechanical model. These are probable region of electrons, right, where electron may be found, where the probability of finding an electron is maximum, right? We call these regions where the probability of finding an electron is maximum as orbitals, right? So these quantum numbers will tell us the exact location, energy, and the shape of orbital and the orientation of orbital and what kind of orbital or shell the subshell the electron is in, right? So it, in short, these quantum numbers will tell us the exact location, energy, right, type of orbital and shape and orientation of an orbital. If you remember, we have understood each of these things in the wave mechanical model of atom when we studied the solution of Schrodinger equation. All these information is provided by the solution of Schrodinger equation. That is why we said there in that lecture we haven't discussed much that the solution of Schrodinger equation give the information on first three quantum numbers. We have total 4 quantum numbers. The first 3 quantum numbers are provided by the solution of Schrodinger equation, right? We'll just quickly see how it does. Shape and orientation of orbitals, right? Orbitals are region where you have electrons, right? So location of orbitals is the location of electrons, we can say that, right? So the Schrodinger equation was this: H psi is equals to E psi, right? For the simple hydrogen atom we have studied. If you solve this Schrodinger equation for the simple hydrogen atom that has only one electron in its outermost shell, you can solve this Schrodinger equation exactly, right, for electrons that have one electron in the outermost shell, like hydrogen and hydrogen like atoms, right? Some ions that we have studied which have only one electrons like hydrogen. So we solve this Schrodinger wave equation for values of E and psi, right? We solve it for E and psi, right? And we have discussed that the value of E will tell us the energy levels that an electron can occupy, right, in hydrogen atom. Now the value of psi will tell us what the value of psi. What is psi? Psi is a wave function, right? And why we call it a wave function? Because if you remember, electron is what? Electron also has a wave character, right? So the wave character of the electron will give it a wave function, right? This wave function is due to the wave character. As we have multiple electrons in an atom, so we have multiple wave functions for an electron, right, for the electrons in an atom. So this wave function represents your orbital, right? You can visit the previous you can just watch the previous video lecture, because in there I have explained the solution of Schrodinger equation in detail. If you have any doubts on this, right, then come to the quantum numbers. It would be easy for you to understand, and then only you can understand the main concept behind quantum numbers, right? So psi is first it's a wave function, right? It has all the information of electron, we said, right, all the information of electrons, and its value depends on coordinate axis x, y and z, right? and we said that this wave function, this psi, this wave function psi, this represents orbital, right? And what is orbital? Orbital is nothing but where you have electron, right? Electron is contained in orbital, right? And how we constructed the orbital, or how we determined the shape, right, and the size of the orbital using the probability density, right? The shape of the orbital was determined using the probability density, and the shape of the orbital was nothing but the electron cloud, where the probability of finding an electron is maximum, right? So it also tells us it represents the orbital, and orbital is nothing but your electron cloud, right? And as I said, that its value depends on the three coordinate axes, x, y and z axis. Why? Because this represents an orbital, and orbital is there in your atom, right? And we say that its value depends on x, y and z axis. That means this orbital is your three-dimensional. Orbital is three-dimensional. Three-dimensional we mean like this. It's oriented in all the three dimensions, right? So because we have considered that the atom is three-dimensional in quantum mechanical model of atoms, so this electron where the probability, this orbital where the probability of finding the electron is maximum is also three-dimensional, which is represent this wave function psi, and whose value depends on the coordinate axis x, y and z axis. So this is important to understand. So in a way, what this tells us, the psi, it tells us, it represents the orbital, right? It represents the type of orbital, right? What type of orbital it is, right? And the type of orbital will tell you its orientation in space, right? Because we said we have one more thing. This represents an orbital. There is another thing, square of psi. This was your probability density, right? So this orbital, right, orbital which is an electron cloud, is constructed using the value of psi square at various points in three dimensions, right? So using psi square, using this value of psi square, we construct electron cloud in three dimensions, right? And this psi square represents probability density at various points in space, at various points in three-dimensional space, right? So if I calculate, if this is your three-dimensional space, right, if I calculate this psi square, if I know the value of psi, I will calculate psi square at various points in x, z and y axis, right? So maybe this point, the point will represent the probability density, right? So if this is the kind of structure that I will get, which represents the probability of finding an electron around the nucleus, right? So this is your electron cloud, right? And how I construct these dots are constructed using the value of psi. If I do the square of psi, what I get is this kind of a shape, right? What this shape is, this shape represents an orbital, and what I am calculating by this, the value of psi square, is probability of finding an electron. So the probability of finding an electron would be like this. This is the shape that I am getting in three-dimensional, where the probability of finding an electron is maximum. So this shape is your spherical, right? Similarly, you may find like this, you may find a region like this, right, where the probability of finding an electron is maximum, right? So, and you may find it like this also, right? This is in x-axis, this is in, like, this is your z-axis, right? So these kind of electron clouds, right, you will get, right, when you find the probability of an electron, right, using the value of psi square. So that is why we say that psi represents an orbital, because using this value of psi you construct these electron clouds, right, and these electron clouds are nothing but orbitals where you have electrons, right? So now let's just quickly see these quantum numbers. As I said, that the value of E, when you solve Schrodinger equation, you get the value of E, right, and you get the value of psi, right? We have discussed about psi now. Using the value of psi, you can construct these electron clouds, right, these kind of electron clouds, and what these are giving you, the shapes of orbitals, right, and these will also give you the size of the orbitals. We will see how, right? And these will, the value of psi will also tell you the orientation of orbitals in space, in 3-dimensional space, right? So these are the information, shapes of orbitals, right, using the value of psi square, size of the orbitals. Size of the orbitals, I will just discuss this once we understand E, and it also tells us the orientation of orbitals in 3-dimensional space. If you can look at this, this is your spherical orientation, right? And if you look at this, this is oriented in z-axis. This electron cloud is oriented in z-axis, and this is oriented in your x-axis. Similarly, you can get another one like this. This is your y-axis, right? This is your z-axis. So these orbitals are oriented in 3-dimensional space, right? So the energy levels that an electron can occupy is given by the value of E when you solve Schrodinger equation, and this tells us the various energy levels that an electron can occupy, right? And this is represented by N. These energy levels, if you remember, this was, we draw orbital diagrams, right, in your class 9th and 10th, right? So this is how we represent these electrons. These represents the value of N, right? So these are the energy levels that an electron can occupy, which is represented by N. So we call it as principal quantum number. Principal quantum number, right? And this principal quantum number will tell you the energy of the electron, right? It tells us the energy of the electron, right? Because we said quantum numbers tell us the energy of the electron. So N, the value of N will tell us the energy of the electron, right? And it also tells us the size of the electron cloud, right? Like I said here, the size of the orbitals or the size of the electron cloud. The size of the electron cloud, let's leave this. Size of the electron cloud, right, is decided by the value of N. More is the value of N, that means more is the distance of the electron from the center of the nucleus, this is the nucleus, and this is N is equals to 1, and this is N is equals to 2. Similarly, if you have a third shell, this is N is equals to 3, this is N is equals to 4. So more is the value of N, right? This is N is equals to 4, this is N is equals to 3. More is the value of N, more is the distance of the electron from the nucleus, right? So for this electron, if you construct this kind of a electron cloud, right, it would be somewhat like this, bigger, right? And if you will construct the electron cloud for this electron, which is nearer to the nucleus, it would be like this, like this, like this. These are spherical orbits, right? I'm sorry, these are spherical orbitals, right? So these, the value of N, right, will tell us the size of the electron cloud or the size of the orbital, right? We'll see how. we'll just look at this in a moment. So it tells us the energy. How energy? If an electron is far from the nucleus, more is its energy. More an electron is far from the nucleus, more is its energy. Why? Because there is an attraction due to this positively charged nucleus, right? This nucleus is attracting these electrons. So since there is an attraction by this nucleus, so more you take away this electron from the nucleus, more is the energy that you need, right? So more energy is applied to take the electron to the outermost shell. That means the outermost shell has maximum energy, right? That means the outermost shell, the electrons that are in the outermost shell has maximum energy, because maximum energy is required to keep the electron in the outermost shell, right? Because of the attraction by the nucleus. So it tells us about the energy, and energy is given by minus, it's m e to the power of 4, it's h square pi square m, the formula for energy that we have done before, 2 pi square m e to the power of 4, 2 pi square m to the power of 4 n square h square, right? So you can look at from this also that energy is inversely related to 1 upon n square, right? Since here we have a negative sign, more is the value of n, right? Less would be this quantity, right? So energy is, more is the value of n, right? Higher would be this quantity, right? Because we have a negative sign here, so more is the value of n, more is energy, right? More value of n means you are moving away from the nucleus, and higher is the energy, right? So these are the two main information provided by principal quantum number. It tells us it determines the energy of the electron, right, in hydrogen atom and hydrogen like atoms. Like I said, using Schrodinger equation, we can determine the energy of hydrogen and hydrogen like atoms, right? And if an atom has multiple electrons, 2 or more than 2 electrons, then we cannot determine the energy of those electrons using Schrodinger equation or using these quantum numbers exactly, right? Because if you remember, the Schrodinger equation will become very complicated. It's difficult to solve that equation, the Schrodinger equation, because of the repulsion between the electrons, right? Because of the repulsion between the electrons, this equation will become very complicated, due to which we cannot solve it exactly. So we have to adopt various approximate methods to determine the energy of those electrons, right? So it tells us two things: energy and the size of the electron cloud. How the size of the electron cloud, I'll just come back to this, right, once we understand this second quantum number, which is your azimuthal quantum number. And here I said that the shapes of the orbitals, these are the shapes of the orbitals, right, which we constructed using the value of psi, right, and psi square. So these shapes of the orbitals, right, the shapes of the orbitals is given by another quantum number called as azimuthal quantum number, right? So the shape of the orbitals, this is given by azimuthal quantum number, right? And azimuthal quantum number denoted by L, its value is 0 to n minus 1, right? It tells us about the shapes of the orbitals. We'll see how it, okay, let's just, since we have understood this is your s, it has spherical shape, so this is your s orbital. This has this kind of a dumbbell shape, right? So these are your p orbitals. This is pz, px, this is your py. These are 3 orbitals, right? So, and we have other orbitals as well, like d orbitals, f orbitals. They are more complicated in shapes, right? So this is L is equals to, so the number of how many these are, we also call these as subshells, right? So these are your, if for n is equals to 2 value, L is equals to 0 to n minus 1, that is 2 minus 1. You have 0 to 1, that is 0 1, right? For n is equals to 3, you have the values of L 0 1 2, right? So this 0, I'll just write it over 0 1 2 3, right? These represents, what does these represents? The shapes of the orbitals. P orbital, right? This is your D orbital, this is your F orbital. S, P, D, F. This is how we represent. Now, we said that this is for n is equals to 2, you have 0 and 1 orbital. For n is equals to 1, for n is equals to 1, you have 0 to 1. You have just 1. The value of L is equals to 0 for n is equals to 1, right? Because 0 to n minus 1. So 1 minus 1 is 0. So for n is equals to 1, L is equals to 0, right? So here, this is your spherical orbital in first shell, in first energy level. We will represent it with 1s. Here, we have calculated these 3 orbitals or subshells for your n is equals to 3. So we will represent it like this: 3s, 3p, 3d and 3f, right? And if this is L is equals to 2, we have 0 1. So this is like 2s and 2p, right? So it basically what you need to do is to represent an orbital, you put the number corresponding to the energy shell. Like here we have n is equals to 3, so we will put the number of shell 3 first, then the orbital, right? Like we want to mention s orbital, so s, p, d, right? First we will mention 3d orbital. So we said that n, right, we have gone through this point, this size of this tells us the size of the orbital. So how does it tells us the size of the orbital? 3s orbital and 2s orbital, 1s orbital, right? So you have here energy shell, these s orbitals, which is the biggest, which one has the bigger cloud? 3s, because 3s is in out, the 3s orbital belongs to the third energy shell, 2s belongs to the second energy shell, 1s belongs to the first energy shell, right? So the biggest electron cloud is of 3s energy shell, right? Similarly, this one has the highest energy because this is of outermost energy shell, right? So this one has, we can write it like, for size, 3s is greater than 2s, this is greater than 1s, right? So this is how we can determine the size of the electron cloud. Now we are clear that azimuthal quantum number tells us the size of the, it tells us the size of the electron cloud, or I'm sorry, the shape of the orbital, right? So it defines the basically it defines the 3-dimensional shape of the electron, right? I'll write it over here, 3-dimensional shape of the electron, right? Now the number of subshells in the principal shell is equal to the value of n. Like here we said, this is n is equals to 3. N is equals to 3, we have how many orbitals? For n is equals to 3, we have 3 orbitals, right? 1, 2, 3, right? Similarly, this 0, 1, 2. If this is not, sorry, this is not. For n is equals to 3, we have 0, 1, 2 orbitals, right? So for 3, n is equals to 3, we have 3 orbitals. Similarly, here for n is equals to 2, we have 2 orbitals, 2s and 2p, right? For n is equals to 1, we have L is equals to 0, only 1 orbital, right? So this number, the number of orbitals is equal to the number of the principal quantum number. Now the third thing is the orientation of orbitals, right? This is also provided by the value of psi, because using the value of psi and psi square, we have found the probability of finding an electron in 3-dimensional, right? And we saw that the probability of finding an electron in 3-dimensional is is in three-dimensional. These are the, I mean, when we draw the probability of finding an electron in three-dimensional, we will see that the probability of finding an electron is more in specific orientations, more in some specific orientation than others. Like here, the probability of finding an electron is maximum in this orientation, right, than any other orientation. Similarly, probability of finding an electron is maximum in this x-axis, in this orientation, rather than in any other orientation, right? So this orientation of orbitals in three-dimensional space, right, is your given by third quantum number, which is your magnetic quantum number. Magnetic quantum number. This is represented by ml, right, and its value is given by 2l plus 1. Right, the values of 2l plus 1 will tell you these different orientation that an electron can have in three dimensions, or that an electron can have in three-dimensional. So in a way, this value 2l plus 1 will give you the probability of finding the electron in different orientations, right? If this value gives you three orientations, right? Because if the value of L, that is first shell, the value of L is equals to 1, we have the value of ml would be 2 into 1 plus 1 is equals to 3, right? That means we have three orientations, right? And these three orientations represent this one represents this p orbital, right? And this is p orbital, and using magnetic quantum number we have found its orientation. We have three orientations, and these three orientations are these in three-dimensional, in three coordinate axis, right? So I'll repeat this value. I'll repeat from the beginning. The value of n will tell you the principal quantum number. This tells you the principal quantum number, and its value is like 1. If its value is 1, then the value of, let's say let's find it for principal quantum number 2 for second energy shell. L is equals to 0 to n minus 1, which would be 0, 1. Similar, then the ml would be how many orientations? This 0 represents your 2s orbital and 1 represents your 2p orbital, right? Now what could be how many orientations does 2s orbital have? For 2s orbital, L is equals to 0, right? So 2l plus 1, so would be for 2s, we have 2 into 0 plus 1, right? 1 orientation. For 2s spherical, it's only 1 orientation. Similarly, for 2p, 2 into 1, right? P is equals to 1 for the p orbital, right? So plus 1, 3. ml is 3 for p orbital. That means p orbital has three orientations in three dimensions, right? And now there is a fourth quantum number. Besides these three quantum numbers, we have another quantum number, which is your spin quantum number, right? Now the spin quantum number, what does the spin quantum number will tell you? That since an electron is moving, right, like this is an electron which is moving, right, around the nucleus. Instead of moving, it is also, in addition to moving, this is also spinning, right? This is spinning, right? An electron can spin in two directions. It will spin anti-clockwise, right, like this, or it will spin clockwise like this. So there are two directions in which electron can spin, which is your clockwise direction and anti-clockwise direction, right? So these are two spin states, anti-clockwise and clockwise. Then these are represented by two arrows, up arrow and down arrow. And if an orbital has two electrons, both the electrons will